Hello, and you are welcome to Chuks Science tutorial. And this is physics class with Chuks. So I will try as much as I can to make you success. That is if you can follow the channel. Alright, now the topic for today is reflection of light by curved or spherical mirror. Now, curved or spherical mirror. What is curved or mirror? Now, a mirror that is not flat, it's not plane, it's bent. It's bent like this. Is called a curved mirror. You get it now? So if outside is coated or silvered, such that inside we call the reflecting part. Now, and if this is an incident ray, and this is a reflected ray, incident ray, reflected ray, incident ray, reflected ray, incident ray, reflected ray. This is a straight line passing through. Now we call this type of curved mirror concave mirror. Concave what? Mirror. You see now? Now, but if inside is coated or silver, inside is coated or silver like this, such that outside the mirror become the reflecting part like this. See now? See now? Like this. Like this. Alright, and if I could trace the reflected ray, I'm going to get a visual focus here. This focus here is not real. You see now, and there's a line here. It's okay. So we call this type of mirror convex mirror. You can call this one concave or converging. You call this one convex or diverging. Alright. So that is that we have two types of curved mirror, concave mirror and convex mirror. Now, at this point, you have to know some of the words that you should master when come to this topic. Word like one, convecture, or call it center of convecture. Two, you have to know the meaning of radius. Radius of what? Convecture. Three, you have to know what we mean by principal axis. Principal axis. So you have to know next one, principal focus. And have to know the meaning of focal length. It's okay. Now, like as I have drew before, if this is a curved mirror and this is, we call this place pole. That is the center of reflecting part of a curved mirror. Now this straight line is what we call principal axis. Now let's assume that this is the center, and it is given that if, for instance, of course, this mirror is just a part of a sphere. The curvature of a sphere. Now, if the center of the sphere, see now, this is the mirror, the other one is removed already. Now we call it the center. We call it center of what? Curvature. Now it becomes the center of the sphere, of which this mirror is part. So that's the meaning. Then radius of curvature is the distance from here to pole. It's called radius of curvature. Now, a point along this line, we call it the principal focus. where, and that is principal focus. This is principal focus. So that point where all the rays parallel, of course you can see now, they are parallel and close to principal axis. See there now, that these rays, they are parallel and they are close to principal axis. You know, come to converge. After reflection is what we call principal focus. It's okay. Now, focal length is simply means half of its radius of curvature. Focal length, we use small f, is equal to what? Half of what? Radius of curvature, so r over 2, mathematically, that is the meaning. Now, so before we continue, I would like to give us, tell us what to happen to image, or I call it the nature of image formed by each of these mirrors. Now, for instance, if you take concave mirror to discuss, now what are the nature of images they are going to produce by using concave mirror? Now, for instance, let's start by saying image or nature of image. Nature of image formed by concave mirrors. Now, generally, I want to tell that the nature of image you are going to produce using concave mirror depends the position of that object before the mirror. It depends where you place the object in front of the mirror. For instance, now, if the object is placed, beyond center of curvature, which we will see to represent what will happen to the image. Now let's make a short diagram here. This is my concave mirror. This is my principal axis, and this is my center of curvature. See? So if I put my object here, the distance before C, I use O to represent object, and this is the head of that object. So there will be a reflection now. Of course, there will be a reflection. Yes. Now this thing there will be an incident ray, rather. The incident ray will reflect here, right? We call it reflection. Now another ray will come this side. Yes. Now you see that this line and this line they join here, right? They are going to produce an image there. So this is the image. This is the image now. Now the question, if it's a Waec or Jamb, we ask you what are the nature of image produced here. Now note, this image is smaller than object, right? Yes. So we call it diminished. The image is diminished. Alright, now number 2. Watch this image. This image now, the head is downward. While the object, the head is what? Upward. We call it what? Inverted. We call it inverted. The image is inverted. Now next one. Watch this image. This image is as real as the object, right? So we call it real image. I'm going to produce what? Real image. Now, next one. Note, this point is called principal focus. That's the point of what? A point where the ray will converge. Yes. Now, the image will be found between principal focus F and center of curvature C. So that is a case of image when an object is placed a distance before what? Center of curvature. Now, for instance, if I go closer, I shift my object closer such that the object is having to place at the center of curvature. What will happen to the image? You see now? Now you see, this is the object. That is at. That is my 2. If it placed at C, right? Now if this is just my short diagram, please don't remember that very well. I'm just trying to. I'm going to try it. Now, this is the mirror. This is the center of curvature, and the object is here. Like I said, the head is already right. All right. So this is the incident ray. You see now, and the thing will come this way. You see it? It will come this way. Alright, then another one come this way. Come this way. When you reflect, the thing will reflect back. You see it now? Now this is incident ray, reflected ray, incident ray, reflected ray. This point, you see now, I'm going to get your image. This, don't forget, this object, this image. Now the question is, what are the natures of this image? Number one, look at this thing. It doesn't matter how I draw it, but I believe I tried. Now the image here is at the same size as the object. Yes, same size. Same size. With what? With object. Yes. Number two, watch this image. This image, the head is downward. Yes. We call it what? We use the word inverted. Yes. Keep watching this image, please. This image. What can we say again in this image? This image is as real as object. So I call it real image. Real image. Yes. Remember, this is the center. That is the converging point. Is what you call F, principal focus. And remember this one, center of curvature C. It's okay. And this is my image, I, and this is my what? Object. Now, when can you see the image? Just watch the diagram very well. It's an image is at C, right? So the image is located at C. You can understand now. Now, what of if I decide to shift the image closer like this? I'll get, if I decide to shift an object rather closer, I'll get an image unique and different from all this one that we're talking about. For instance, now, if the image, if the object is between C and principal focus between F and C, what will happen to the image if the object is here? Now, if I place my object here, the image will have the following characteristics. Number one, the image will be bigger than the object. We call it magnified. So the image will be magnified. That's one. Bigger than object size. Next one, that kind of image will still be inverted, turning upside down. Inverted. Now, the image will still be real, just like an object is real. Now, where will you see the image? Please, the image will come this side. If object is here, the image will shift to this side. So it is found where? Beyond C. A distance before C is okay. Now, what of if I decide to shift my object and I place my object at this principal focus? What will happen to my image? So that's my fourth position of an object before the mirror. That is at F. What will happen to the image? If the object is at F, now that kind of image cannot be seen. You can't see that image. Can you hear me now? You will not see that image. So the word they used to describe that kind of image, that image is seen at infinity. So where? Infinity. That's the only thing it can tell me about image. It won't tell me that the image is short or large or big or whatever. The image is seen at infinity. You can't see that, it's very far. Alright. Now if I remove my object and I put my object here between F and pole, what will happen to the image? Now, before I give you, that is number 5 now. That is between pole and F. What will happen to the image? If object is here, note that the image will no longer be here again. The image will be inside the mirror. Get it very well. The image will be inside the mirror, and that's why that image cannot be real again. Because it's not real. We use the word virtual. So that kind of image is virtual. Not real. Not real. Number two, that kind of image will be upright. It will be upright. It will be erect. It will not be inverted again. It will be erect. Upright. Number two, that image will be smaller than the size of object. So we call it what? Diminished. Diminished. Get it now? And when we see the image inside the mirror, it's trying to see inside the mirror. Alright, so these are the things you have to know when come to concave mirror, the images produced. Now, generally for convex mirror, they have peculiar nature. They have similar nature. It doesn't matter where you place the object. For convex mirror, the image must be virtual. Reason being that image will be seen inside the mirror. So that kind of image will not be, real. It's virtual. The image will be smaller than object, which is diminished. Now that kind of image, erect. And at this point, I'll tell you the advantages this convex mirror has over convex mirror, and that's why it is used as a side mirror in cars. You see now because the thing produces image inside the wall, inside the mirror. And for that reason now, the image produced is erect. So the uprightness of image enable a driver to interpret the nearby object. So that, because if the image is inverted, it will be much difficult for a driver to interpret now. So the image is erect. Now the image is this kind of mirror provide wider view. Imagine the driver driving. That's why you can see, you look at the back through the mirror and you can see a very wide environment, space. Because of this kind of nature. But for this one now, concave mirror does not provide, it provide a narrow view. So, and another one that this mirror, convex mirror, has a diminished image. So the diminished nature of image enable other objects coming nearby the car to be captured by that kind of mirror. So that the driver driving can know the number of cars following him or her. You see now? So that is all you have to know when come to this one. Now, before we go to past question, let me explain the meaning of linear magnification. The concept of linear magnification. Magnification. It's okay. When you hear the word magnification, it simply means the number of times an image will be as bigger as that of what? Will be as bigger than object. Number of times an image will be larger or bigger than object. It's what we call magnification. Now, of course, here we use the word magnify. See where you magnify. See here. So number of times the image will be bigger than object. So what called magnification. Now, mathematically, magnification is expressed as magnification is expressed as the ratio of image height, to object height, and you can also define it as the ratio of image distance. We use V for image distance to object distance. We use U for object distance, and this is the formula. I'm going to use to calculate the linear magnification. It's okay. Then the next thing you have to know here is I'm going to look at the general formula for equation of what? Mirror. That is a mirror formula. Mirror what? Equation of a mirror, or call it the mirror formula. Mirror what? Formula. Mirror formula. Alright. So now the formula is 1 over U plus 1 over V equal to 1 over 1 F. Please, this formula is for concave mirror. Yes, because for concave mirror, image is real. Focal length is positive. And I hope you know the reason, because the thing is not inside. Unlike this one, where this will be here, right? So, but for convex mirror, if the mirror is convex, the formula will be negative. Of course, this will be negative, right? This will also be negative for convex mirror, because this is not real, this is not what? Real. This is virtual, yes, this is negative. You get it now? So, when we solve the calculation, you know how I'm going to apply negative one and positive one. So at this point now, let's go to past question and solve past question. So it's okay. So this is the all the questions we solve here, Jamb question. You can still solve a Waec question. Now, before we solve this question now I got to tell you the beginning of all this thing. So V is what? V is object distance from the mirror. U is image distance. F is focal length. Now, for instance, I have given you the formula for magnification, right? Now, you can still connect magnification from this formula. Yes. What will I do? If I multiply everything here by V, right? If I multiply everything here by V, what will I give? Now, this V is here, U comes here. So if I multiply everything by V here, now what I want to do go get it. Now before that, if I times everything by V, I'm going to have V over, that is 1 over V now, times V, right? Plus V times 1 over U equal to V times 1 over F, right? This cancels this now. Remaining 1, right? 1 plus this time is what? Is V by U, right? It's okay. Then equal to what? This time is what? Is V over F. Now, when I gave the formula for magnification, I told that magnification M is equal to what? Image distance, which is V, over object distance, which is what? U. So I'm going to substitute this using M here, right? So 1 plus M equal to what? V over F, right? Now, making this the subject of the formula, I have that M equal to V over F. This is coming this side now because what? Minus what? 1. So this equation is also very, very important because there are questions that demand the use of this formula. Now, this is the question that asked in the year 2005. Now, question number 34. It says, a real image 3 times the size of an object. Now, I define magnification to you as a number of times an image is as bigger or larger than an object. Which means, if they say an image 3 times the size of an object, it means they have given magnification. So, solution. Let's solve this question. My M is given. And it's what? It's 3 without wasting time. Alright, it's formed. That image is formed 24 cm from a converging mirror. Now, you have to note the type of mirror we are talking about is converging. And they say in converging mirror, focal length is positive, right? Image is real. So you don't need to worry yourself. Now, from there, we have given, they gave us the image distance now. And image is represented using V, and the distance is 24 cm, which is the unit. Alright. Now the question is, what's the focal length of the mirrors, which is F? F is what we're looking for. Very simple. Very, very simple. Now, to avoid stressing myself, I will quickly use this formula. Yes, I know my application. Yes, I I know my image distance, yes. I'm looking for this, simple as that. So I will substitute my M is my 3 equal to my V is my 24 all over. My F is what I'm looking for, equal to minus 1. Now, how will I make this equation linear? You have to know math. If more than expert in physics, you have to know math. So how will I make this fraction linear? I'm going to multiply everything here by F, right? So I'm going to have 3 times F is 3F now equal to 24. Yes, 24 times F is what? Is 24F, right? Over F. Am I correct? Yes. Minus what? F times 1. So 3 times F is what? 3F equal to, this can cancel this, right? 24 remain minus 1 times F is what? Is F. I will collect my like terms. So minus F is coming inside. It becomes 3F plus F equal to what now? 24. Add this together, you get to what? 4. F equal to 24. What next? I have to divide both sides out. Let me divide both sides. Divide both sides by 4 now. So 4F over 4 equal to 24 over 4. Right? This cancel. F becomes what? Divide is get what? 6. Put your unit. Right? Now, remember it is plus because the thing is called virgin mirror. So, and that is option C. Please, next question. We're going to solve next question now. Let's solve number 2 question. This was taken from the year 2018. Question number 15. The image of an object is located 6 cm behind a convex mirror. What type of mirror? Convex. So the same image is what? Image is located 6 cm. So V is equal to minus what? 6 cm. I see the difference now. It's okay. If its magnification is 0.6, so M 0.6 cm. Calculate the focal length. F is what you are asked to do what? To calculate. Now I said the short formula to use when you have image, magnification, and you have to find focal length. Just use this simple formula, right? So okay, now the formula is this. My M equal to my V over what? Over F minus 1. Now in this case now, my V is what? Negative, right? Now the F is what I'm looking for. But I told you that for convex mirror, F is still negative, so I'll put negative, right? Now, by rule of division, negative can cancel what? Negative. So it's as good as leaving it like this. Understood now? Yes. So we're looking for what now? We're looking for focal length, which is this. So the same pattern, the following. This one is what? 0.6 equal to this one is 6 all over F equal to minus 1 multiplied to by F, you get to 0.6 F equal to, this will cancel, means 6 minus 1 F, right? As we did last time, as we did here. So you collect like 0.6 F plus what? F equal to what? 6, right? Equal to 6. Add this. Remember this means 0.6 F. This means 1 F, right? And 1 F, that is 1 F times 0 plus 0.6 F will give you 1.6 F, right? Now equal to what? 6. What next? Let me divide by 1.6 by 1.6. This cancel my F becomes equal to F. This can be 60 over what? 60, right? 60 over 60, and I can use 4 to divide. 4 here is 1, 15, right? 4 here is what? 4. Okay. Then 4 here 1. 4 into 15 is 3. 3 remaining what? Remaining 3, which is 30 now. which is 30. 4 into 30 is what? Is 7. Remaining what? Remaining 7. Yes, remaining 2, which is 20. 4 to 20 is what? Is 5. So F will be equal to 3.715. Put your what? The unit. Which option is that? Option A is the correct option. Please, let's go to the next question, please. Let's go to the next question. Alright, so let's solve the mathematical question. Was taken the year 2014, question number 30. Remember, all these are Jamb questions, so she take note of it now. Number 3, focal length of a concave mirror. This is a concave mirror, right? So my F is given now is solution, please. My F is what? 2.0 cm. Now, if an object is 8.0, so object distance u is 8.0 cm, right? So now, if the image is given, so they ask you to find what the distance of the image, which is v. V is what I'm looking for. Now, it's okay. Now the formula, just use mirror formula, please. That 1 over v plus 1 over u equal to 1 over n. We're looking for what? This, right? And just continue 1 over v. Then plus 1 over. This one is what? This one is 8. Leave point equal to. This one is what? Is 2, right? Yes. That will give me making 1 over v the source of formula. We have 1 over v equal to 1 over 2 minus 1 over 8. LCM is 8, right? 2 into 8 is 4. 4 times 1 is 4. Minus 8 into 8 is 1. 1 times 1 is 1. So we have 1 over v equal to subtract the 3 over 8, right? Let me cross multiply now. This time this is what? Is 3v equal to 8, right? Now, divide by 3, get it now. So v becomes equal to 3 divided by 8 is 2. 2 remains, which is 20 now. And then 3 into 20 you get 6, right? You get 6, right? Now you are possibility to 1 decimal place because the answers, all the options are a decimal 1 decimal place. So it should go 2.7 cm, and that's what option A. A is the correct one. Option. This is the channel, and share it to your friends. Also like for their own benefit. Next time, thank you.